How Elon Musk and impossible problems, they're rarely talking about tidy puzzles with clear solutions. They're talking about problems that most smart people quietly decide are not worth touching because the odds of failure are embarrassing, the timelines are brutal, and the social cost of being wrong is high. What's interesting about Musk isn't that he's always right, he isn't, but that he consistently walks straight toward problems that come with ridicule attached. Understanding how he approaches these problems is less about copying his tactics and more about understanding the mental posture he takes before the first calculation is even made. At the core of Musk's approach is an unusual relationship with fear. He clearly feels it. Anyone who has watched SpaceX nearly collapse in 2008 or Tesla teeter on bankruptcy knows this, but fear does not dictate his choice of problem. Most people subconsciously filter ideas through a question like, what will people think if this fails? Musk seems to run a different filter. Is this important for the future, and is it physically possible? If the answer to the second question is yes, embarrassment becomes irrelevant. That alone eliminates a huge psychological barrier that stops most talented people before they begin. He also treats impossible as a temporary label, not a permanent category. In many minds, impossible means the laws of reality forbid it. In Musk's mind, impossible often means expensive, inefficient, or poorly understood. That distinction matters. When SpaceX began talking about reusable rockets, experts didn't say rockets could never land vertically, they said it was economically irrational and technically impractical. Musk heard something different: the physics doesn't say no. And if physics doesn't say no, then the problem is one of engineering, iteration, and cost reduction, not magic. This leads to one of his most famous habits: first principles thinking. While the phrase is overused now, in Musk's case it's not a buzzword, it's a working method. When confronted with a hard problem, he tries to strip it down to the most fundamental truths he can rely on. Instead of asking how rockets are usually built, he asks what a rocket is made of. Aluminum, titanium, carbon fiber, fuel, labor. Then he asks what those things cost at a raw material level. When he did this early on, he realized rockets were far more expensive than the sum of their parts would suggest. That gap wasn't destiny, it was convention. Once you see convention as optional, whole solution spaces open up. What's subtle here is that first principles thinking isn't just analytical, it's emotional. It requires a willingness to look stupid in front of experts. If you ask too many basic questions, people assume you don't belong in the room. Musk seems willing to pay that social price again and again. He asks naive-sounding questions because he genuinely wants to rebuild understanding from the ground up. That's uncomfortable for teams used to hiding behind jargon, but it's often where breakthroughs start. Another key aspect of his approach is the way he treats learning curves. Many people look at a complex problem and assume mastery must come before action. Musk flips that. He often starts acting while still learning, compressing feedback loops aggressively. When he entered aerospace, he wasn't trained as a rocket scientist. Instead of waiting years to become one, he read obsessively, questioned experts relentlessly, and began building and testing hardware as soon as possible. Each failure then became a data point, not a verdict. This tolerance, sometimes enthusiasm, for failure is not abstract. SpaceX's early rockets exploded, sometimes spectacularly. Each explosion was public, expensive, and humiliating by traditional standards. But Musk framed these failures as necessary tuition. He has said more than once that if things aren't failing, you're not innovating fast enough. That mindset reframes failure from something to be avoided into something to be managed. The goal isn't to fail randomly, but to fail in ways that teach you quickly and cheaply compared to the value of the lesson. Time compression is another pattern that shows up again and again. Musk is famous for unrealistic deadlines, and many of them slip. But the deeper point isn't the exact date, it's the urgency he injects into the system. By setting timelines that feel almost absurd, he forces teams to discard comfortable assumptions. When you think you have 5 years, you design one way. When you think you have 6 months, you design another. Constraints become creativity engines. Even when deadlines are missed, the speed of iteration tends to be far higher than in organizations operating on conservative schedules. He also has a habit of vertically integrating solutions rather than outsourcing complexity. When faced with a difficult component or bottleneck, his instinct is often to bring it in-house. This isn't because he distrusts suppliers by default, but because control matters when you're pushing boundaries. At Tesla, when battery costs and performance were limiting factors, the response wasn't just to negotiate harder with suppliers, it was to rethink battery design, manufacturing, and even raw material sourcing. Owning more of the stack gives more levers to pull when something seems impossible from the outside. Another underrated element is his willingness to carry multiple massive problems in his head at once. Most people prefer focus because it reduces cognitive strain. Musk seems comfortable juggling several existential challenges simultaneously: electric cars, rockets, solar energy, brain-computer interfaces. This isn't scatterbrained curiosity, it's a long-term systems view. He often frames his work around reducing existential risks to humanity or expanding the scope of civilization. When you're operating at that level, individual obstacles feel smaller, even when they're objectively huge. This long-term framing also helps him endure short-term pain. When your goal is quarterly performance or social approval, prolonged hardship feels unbearable. When your goal is to make life multiplanetary or transition the world to sustainable energy, a few years of chaos and criticism become acceptable costs. This doesn't make the stress disappear, by most accounts. Musk works himself to exhaustion, but it gives the suffering meaning, which changes how it's experienced. Musk's communication style also plays a role in how he approaches hard problems. He tends to speak in blunt, sometimes awkward terms, focusing on substance over polish. This directness can alienate people, but it also cuts through ambiguity. When a problem is genuinely hard, vague language is the enemy. Clear statements about what is broken, what is unknown, and what must improve help teams align quickly. Even his infamous all-hands emails often boil down to, "Here's the bottleneck, here's why it matters, here's what we need to do now." There is also a moral dimension to his approach that is often misunderstood. Critics sometimes portray Musk as motivated purely by ego. While ego clearly exists, no one attempting these feats is free of it. Many of his choices suggest a deeper value system. He repeatedly reinvests personal wealth into ventures with high failure risk and long time horizons. From a purely personal comfort standpoint, this makes little sense. But if you genuinely believe certain problems must be solved for humanity's future, then not trying becomes the greater failure. Another pattern is his insistence on direct contact with the work. Musk is known for spending time on factory floors, in design reviews, and deep in technical discussions. This isn't micromanagement for its own sake. It's about maintaining a high-resolution view of reality. Abstraction is useful, but too much distance from the ground truth allows small problems to grow into fatal ones. By staying close to the details, he can spot inconsistencies early and challenge assumptions that might otherwise go unexamined. He also seems unusually good at switching between zoom levels. He can talk about colonizing Mars at breakfast and argue about bolt sizes by lunch. This ability to move fluidly between vision and execution helps bridge the gap that kills many ambitious projects. Big ideas die when they never translate into daily decisions. Tiny optimizations die when they're not anchored to a larger purpose. Musk keeps both in play at once. One of the less glamorous aspects of his approach is sheer stamina. Impossible problems require sustained effort over years, often with little external validation. Musk's work ethic is extreme by any standard, and while it's not something everyone should emulate, it's hard to deny its impact. Long hours don't automatically create breakthroughs, but when combined with high-leverage decisions, they can compress timelines dramatically. His willingness to endure discomfort, sleeping in factories, working through weekends, signals seriousness to teams and investors alike. It's also worth noting that Musk doesn't work alone in some heroic vacuum. He actively seeks out exceptionally smart, driven people and then pushes them hard. The environment he creates is demanding and not for everyone, but it's optimized for rapid problem solving. He expects people to take ownership, to challenge him when he's wrong, and to care deeply about the outcome. In such an environment, impossible problems become collective challenges rather than personal burdens. When things go wrong, his response is often to take responsibility publicly, sometimes to a fault. This sets a cultural tone. If the leader absorbs blame, it becomes safer for others to admit mistakes early. That psychological safety, paradoxically, can exist even in high-pressure settings when the goal is learning rather than punishment. For impossible problems, early honesty about failure modes this story close.